Good afternoon, grade 12 learners. I hope you wrote well. Welcome to today's mathematics lesson. My name is Annelen Sindane. The lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is Mathematics Paper 2 revision. Our focus will be trigonometry, as we have revised the other topics before. As I've mentioned, my name is Annelen Sindane. I hope you wrote paper 1 well. My advice to you is, don't worry about paper 1 anymore. I know people will be starting to send their things on WhatsApp groups. Please delete. It's not going to help you in any way. So rather focus on the revision of paper 2. What's done, it's done. And I know you have done well. And for paper 2, we just need to do better than what we did in paper 1. Now, our topic is trigonometry, but I want us to have a look at the structure of our paper 2. We have statistics, which has 17 to 23 marks. We revised statistics. We also have analytical geometry, which has between 37 and 43 marks. We had a look at analytical geometry. We also have Euclidean geometry, which has 37 to 43 marks, and we have looked at those. So our focus today is trigonometry. Now, please have somewhere to write, because I would need us to revise through writing so that we are able to see where we stand in terms of our trigonometry. Now, these are our targeting. If we need to get about 45%, we need to get, for our statistics, we need to get a minimum of 12 marks, a minimum of 15 marks in analytical geometry, and a minimum of 20 marks for our trigonometry, and a minimum of 10 marks in Euclidean geometry, which accounts for 57 marks. For us to get a bachelor pass, our aim in paper 2 is to get at least 100 marks. For statistics, we try to get 15 marks. Analytical geometry, we get 25 marks. It's feasible and it's doable. For our trigonometry, 35 marks, and for our Euclidean geometry, we get 25 marks. From the previous questions, these are normally statistics, is question 1 and 2. Analytical geometry is normally question 3 and 4. And then trigonometry is normally question 5, 6, and 7, but it will depend on how the paper would look like. Now, and then we have Euclidean geometry as the last questions in our question paper. Now, we have our information sheet. Please, let's make sure that we use our formula page and we refer so that we do not easily lose marks, because we miss out. We write wrong formulas and we substitute in wrong formulas and we end up losing marks. Now, this is the first part of our formula page. And then we have our second part, which has the formulas for our statistics. On top, we have our formulas for our analytical geometry, distance formula, midpoint formula, equation of a straight line. We have our gradient formula. We also have our angle of inclination. Let's look at that. And then we have the equation of a circle, center AB. And we know that if the center is at the origin, our equation of a circle becomes x squared plus y squared is equal to r squared. Now, we also have our formulas for trigonometry. We have our sine rule, we have our cosine rule, and we also have our area rule. We will look at these a bit later. Now, we have our identities that we are going to be using a lot as we answer questions as we move along. Now, trigonometry. Please note, our questions in trigonometry, normally they will start with a question where we are given a diagram where you are supposed to find the trigonometric ratios without using a calculator. Now, please let us adhere to instructions. It's a must that we adhere to instructions. When the question says without the use of a calculator, it means we must use a diagram, or we are expected to use our reduction rules or our special angles. We should not use a calculator to evaluate alpha or theta if the question says without using a calculator. Otherwise, we'll lose marks because we have not adhered to instructions. Now, our double and compound angle identities must be known and we must be able to use them. The common mistake that you will make, you will find a question says simplify the following. Someone is given sine 90 minus x. Yes, we have our compound angle identities. Someone will go then sine 90 cos x minus cos 90 sin x. The question just says simplify. So here we are using our reduction rules. We are not using our compound angle identities, so that we are able to look at the questions and we are able to answer it accordingly. We should not mix up issues. We move on to the next one. We know that instead of expanding sine 180 minus 2x, we use our reduction rules and we get that one as sine 2x. If we need to simplify further, then we know the identity for the double angle sine. Now, we move on now. Simplifying algebraic expression, it's always a must when it comes to trigonometry, because we are simplifying, we are expanding, we have to show and write in its simplest form, find the value of. So we should be able to simplify our algebraic expressions, and we know the order of our operations, our board mass, we know what to do there. Now, we should always be able to identify which trigonometric ratio to use and also which quadrant to work with, as well as the correct sign of the ratio in the given quadrant. This will come with our reduction rules. We know that the emphasis is on reading, interpreting, and we should understand the given statements in order for us to use the information correctly to answer the asked question. Now, our approach to questions. 1, we should read and understand the question, scenario. We should use the diagram effectively if there is a diagram. We analyze or sketch a diagram to help us interpret the question correctly, depending on the scenario that we are working with. We need to interpret the question, extracting key information that can help us to actually answer the question, and we select the correct formula or identity to use, and we substitute correctly, performing some appropriate arithmetic calculations without a calculator. Now, remember, one must always answer the question, and we remember to conclude exactly what the question wanted us to look at. if the question said calculate the value of sine theta, we must at the end, therefore sine theta equals. We must find that value in simplified form if it requires us to give that as a simplified ratio. Now, we know that our trigonometric questions have follow on in terms of scaffolding, and we have to look out for that, as you might need some information that you have already provided in the previous question to answer the next question. But we have to be careful. You cannot use an answer for 1.23, for example, to answer question 1.21. That's not scaffolding. So if they said show that something is that, you have to show it. You can't use what you are given to show what you are supposed to show. Now, let's quickly have a look at our reductions. We know that we have got our quadrants, and we know that given we are able to find the value of sine theta in any quadrant using the ratio sine, it's y over r, cos is x over r, and tan of any angle is given by y over x. This will remember, we form a right angled triangle. This is our x and our y, and that distance becomes the radius. We can form a circle, and we are able to find the size of our angles in any of the given quadrants. So we have our 0, 90, 180, 270, and we have our 360. We move in an anti-clockwise direction. If we move in a clockwise direction, we are working with negative angles. Now, in the first quadrant, our x is positive and our y is also positive. In the second quadrant, we know that our x is negative and our y is positive. In the third quadrant, our x and y are both negative, and in the fourth quadrant, our x is positive and our y is negative. It is important that we remember this because this determines the sign of our trigonometric ratios in the given quadrants. In quadrant 1, all our trig ratios are positive because our x and y are positive. In the second quadrant, we know that our x is negative, hence our cos and tan are negative in the second quadrant, whilst our sine ratio is positive. In the third quadrant, our tan ratio is positive because it's y over x. Both our x and y are negative. Hence, when we divide a negative by a negative, we get a positive. And then in the fourth quadrant, we know that our x is positive and our y is negative. Hence, only our cos ratio is positive. Now, let's look at our reduction rules. Like we can see in the first quadrant, it's either we are dealing with theta or 90 minus theta there. And we will have the reduction of sine 90 minus theta as cos theta. It's a co-function. Sine becomes cos and cos becomes sine. Cos 90 minus theta is sine theta. And then we have in the second quadrant, either we are working with 90 plus theta or we are working with 180 minus theta in the second quadrant. So, for 90 plus theta, we have sine 90 plus theta being cos theta and cos 90 plus theta being negative sine theta. This is a common mistake that we make. It's because in the second quadrant, cos is negative, hence the ratio becomes negative sine theta. We move on to the next one, sine 180 minus, we have our reductions there. We also have our sine 180 plus in the third quadrant. we know that we get negative sine theta, negative cos theta, and tan theta there. In the fourth quadrant, it's 360 minus theta. We have that as negative sine theta. We also have cos 360 minus theta as cos theta, and tan 360 minus theta as negative tan theta. And then we have our negative angles. The reduction of sine negative theta will give us negative sine theta, and the reduction of cos negative theta will give us positive cos theta, and we have our tan negative theta as negative tan theta. I hope you are seeing this part. I said if you are moving in a clockwise direction, our angles are negative, which means here we'll have negative 90, negative 180, negative 270, and then we have our negative 360 there. Now, that is why you will find cos negative theta is in the fourth quadrant and cos is also positive in the fourth quadrant. That is why that ratio is positive. And if you check, our sine and tan ratios are negative, because if you check in the fourth quadrant, sine and tan are negative. Now, I hope we are seeing how we get these reductions, and I'll encourage you, whenever you are answering a question for reductions, do your reductions in brackets so that you have a track of your signs. You don't lose track of your signs there. And then we also know that we have reductions where angles are above 360 degrees. So what you do, you always subtract until you get an angle which is less than 360 degrees. Sometimes when you are given negative angles, for example, you are supposed to simplify sine. You are given sine x minus 180 degrees. You can see that this is not the normal one, because the normal one always starts with 180 minus 180 plus. So this one, it's a rare one. So what you can do, you can also add 360 there so that you work with the ones that you are used to there. Because I know some factoring the negative sign becomes a challenge and we mix up signs there. So rather, if it's given like this, add your 360 so that you work with your positive angles and not your negative angles. Then it will be easy to identify the quadrants that you are working with and therefore the reductions. Now, with identities that we did in grade 11, cos squared plus sine squared theta is equal to 1. We must always be able to use this identity. Tan theta is equal to sine theta over cos theta. We should be able to use this identity. Now, I don't want to talk too much. So what I will do now, I'll give you an activity and give you 6 minutes to answer that activity 1. We'll mark it and then we move on to the next activity. Let's start. We can be reading that question. I will tell you when to start answering. Yes. Now you may start answering. I hope you have managed to read the information. Let's answer our question 6.11 up to 6.13. We will be back after 5 minutes. Welcome back. I hope you have had a good warm-up question to help you revise trigonometry. Now, on the information given, we are given the point P in the diagram, P with coordinates -5 and 12, and T lies on the positive x-axis. POT is equal to theta. We have to answer the following questions. Here is the instruction without using a calculator. We can't have a decimal. We can't have the value of an angle because there's no way you can get a decimal without using a calculator, or the value of an angle without using a calculator. Now, remember what we said. Always, this is a point on the Cartesian plane. So at point P, our x is -5 and our y is 12. What are we missing now? We are missing our r. That's how we approach questions. So let's check. 6.11. Write down the value of tan theta. Do we need r for 10? No. We can answer that one because from definition we said tan is equal to y over x, which means this one we can answer straight away. Our y is 12 over -5, which gives the whole fraction as -12 over 5. We get our 1 mark there. 6.12. Calculate the value of cos theta. From our definition, we said cos theta is equal to our x over r. Our x we have, but we do not have the value of r. Remember, we are in the Cartesian plane and we drop a perpendicular there to form a right-angled triangle. We know that our x is that side, -5. Our y, it's going to be 12. Then we need to get the value of r. We shall use our theorem of Pythagoras to find the value of r, in which case we will find out that our r squared is equal to x squared plus y squared. R squared becomes -5 squared plus 12 squared. This gives r squared as 169, and we get our r as 13, and therefore our cos theta becomes, our x is -5, our r is 13, we get -5 over 13. Now we move on to the next question. Now here is a nicer handwriting than mine. So this was 3 marks. We get a mark for using theorem of Pythagoras, and then our answer at the value of 13 there will give us our cos theta as -5 over 13. So if you check, this is 4 out of 8. That's 50% of the marks. This is how we get marks as we move along. Remember, we said the minimum target for our trigonometry in this case is 20 marks. And so far we know that we can get these 4 if it comes, and we can also get the next 4 if it comes, and we get our 8 marks there. Let's check the next one. In the diagram, PT, we have read this one. 6.13 says, S with coordinates A and B is a point in the third quadrant such that TOS is equal to theta plus 90 and OS is equal to 6,5 units. Calculate the value of B. Now, TOS, so it means we know that this one is theta. We form another right angle, and We know that our S will then be in the third quadrant because we need to put a 90-degree angle there so that we have something like that. Now, we are supposed to calculate the value of B. How do we get the value of our B in this particular case? If you check, we are given the value of OS and we are given the other part that we already had. Let's get our answer there. That is the first thing that we look at. We are able to see that our sine 90 plus theta is equal to, you are able to see that this becomes our B over 6,5. What is the reduction of sine 90 plus theta? This will give us our cos theta is equal to B over 6,5. And then from there, in our previous question, we calculated the value of cos theta and we found it as negative 5 over 13 is equal to B over 6,5. From there on, we are able to simplify. We will get our B as equal to negative 5 times 6,5, all this over 13. This is the arithmetic that you are computing before you use your calculator. Changing the subject, and then this will give our B as, if you check, it should give us negative 5 over 2. So for knowing that one, we get 1 mark. The reduction, substituting, and then we get our answer. We get our 4 marks there. Now, there's an alternative that we can use there. So we get our B as negative 5 over 2. I'll quickly run through the alternative that we can use to help us answer the questions. We can have cos 90 plus theta is equal to A over 6,5. Why the A? Are you able to see that's our angle that we are dealing with. 90 plus theta, we are working with that angle. Our A, we are in the third quadrant over 6,5. We know that we make that one, we form a smaller triangle there, and we are in the third quadrant. It becomes A over our R, which is 6,5. Then we get our answer there. We will get that one as negative sine theta. We get our A first as negative 6, and then we use theorem of Pythagoras to find the value of B, and it will be 6,5 squared minus negative 6 squared, and we'll get that one as negative 5 over 2 because we are in the third quadrant. We will still get our 4 marks there. We move on. I will give you 3 minutes to quickly work out that activity. 3 minutes. Let's work out that one where we use our compound angle identities. coming back. Our focus now is on paper 2. Now, let's work together so that the more you write something down, the more you will not forget it. Now, we are given cos A minus B as equal to cos A cos B plus sin A sin B. I hope you remember this identity from our formulas. Even if alpha or beta is used, it works the same way. Or they can use X or Y, it will always work the same way. Use the formula for cos A minus B to derive the formula for sin A plus B. Use the formula to derive the formula for sin A plus B. Where do we start? From our identities, I know that sin theta, so I can put theta here. I know that if I have sin theta from my reduction formula, it will be the same as saying cos 90 minus sin theta. If I take this whole thing as theta, it is the same as cos 90 minus theta. But in place of that theta, I have put A plus B. So that's how we use our identities. I know that sin A plus B will be equal to, if it will give me cos 90 degrees minus A minus B, distributing the negative. Negative times A, negative times positive B. I then have my identity like that. Using the expansion of cos, this will give me cos 90 degrees minus A cos negative B. And then what else do we have? It's a minus, and I know that it's a plus here. Sin 90 degrees minus A times sin negative B. Now, what will we have? Sorry, it's not negative B, sorry. There, the negative is not there, because from the formula cos, it's a plus there, and we have our A and B. Sorry about that. Let me quickly fix that. And then we will have this as the reduction of cos 90 minus A. We know that this will give us sin A. The reduction of cos B is going to be cos B, plus the reduction of sin 90 minus A will give us cos A. And let me use my bracket so that I take care of my signs. And then the reduction of sin B remains as sin B, and this will eventually give me sin A cos B plus cos A sin B, which is the identity for sin A plus B. Now, we should get 1 mark for that one. We get a mark for the knowing the distribution of our negative sign there to give us that, and the expansion, then the simplification. We get our 3 marks there. Now, this is how our solution would look like, and we get our answer as such. We move on to the next one. This one, it's in terms of a variable. Given that sine 16 degrees is equal to P, this one, it's either we use our reductions or we have to draw a diagram identifying the quadrant where we are working with. It says determine the following in terms of P without using a. You can see that this word is always bolded so that we don't miss it. But I don't know what happens when we get into the exam room. We forget to look at that. Sine 196, what will we do? We are able to see that this one, we can write it as sine 196 degrees is sine 180 degrees plus 16 degrees. Which quadrant is this one? It's in the third quadrant, and in the third quadrant sine is negative. We get negative sine 16 degrees, which will give us negative P. Cos 16 degrees, also it's 2 marks. How do we get cos 16 degrees? Again, this will require us 16 degrees is in the first quadrant, and we know that if we are given sine 16 degrees is equal to P, this is P over 1, meaning we are able to say we do not have our x, but our y value is P because this is y over r, and our r is equal to 1. We then use theorem of Pythagoras to get our y value, which will give us our p squared plus y squared is equal to 1 squared. And we get our y squared as equal to 1 minus p squared. Our y becomes plus or minus the square root of 1 minus p squared, which is the same as saying y, because we're in the first quadrant, 16 degrees is in the first quadrant, and in the first quadrant, our x values, our y values are going to be, what have I done here? Let me fix it quickly. I'm working with sine. I need x, so it's x squared plus p squared is equal to 1. We get our x squared as equal to 1 minus p squared, and we get our x as plus minus the square root of 1 minus p squared. Therefore, my x will be square root 1 minus p squared. Therefore, cos 16 degrees will be equal to our x over our r, which is equal to square root 1 minus p squared. The other alternative that we can use there, from our identity, we have our sine squared 16 degrees plus cos squared 16 degrees is equal to 1. Then we will have our cos squared 16 degrees as equal to 1 minus the sine of 16 degrees squared, and that will give us 1 minus p squared. Because it's a cos, we find the square root, then we'll find our cos as square root of 1 minus p squared. We move on now to the next question. This one I'll give you 5 minutes to reduce. I'll give you 5 minutes. Let's do the reduction of that one. welcome. I hope this was a good snack. Now, let's quickly do it together. If you check, I'll just write equals. This is my sine 2x. For now, I'm not changing it. The reduction of cos negative x, I know this becomes cos x plus cos 2x. That one is not changing. The reduction of sine 360 degrees minus x, this will give me negative sine x over the reduction of sine 180 plus x. It's in the third quadrant. That will give us negative sine x. How many marks so far? We will get a mark for the reduction 1, a mark for that reduction, a mark for that one. We are having 3 marks so far. Now, if we use our identities for sine double and cos double, this will be complicated. But what do we realize? When we apply, you will find out that this is the same as saying it's sine 2x cos x, a positive and a negative will give us minus cos 2x sine x, all this over negative sine x. Now, remember, if you look at our identities, this is the same as saying sine alpha cos beta minus cos alpha sine alpha. So this is actually sine alpha, which is 2x, minus beta, which is x, all this over negative sine x. And sine 2x minus x, it will give us sine x over negative sine x. And this sine x and sine x, this will eventually give us our answer as negative 1. So now, for being able to see that this is an identity, you'll get a mark, and the final mark for the answer, we get our 5 marks. Quick look. This is what we got, then this is what we got, and then we got our answer as negative 1. So we should be able to identify the expansion of our compound angle identities as well as working in reverse so that we are able to simplify things using them. Now, I'll also give you the next one. I'll give you 5 minutes. We are given that x plus 1 over x is equal to 3 cos a, and x squared plus 1 over x squared is equal to 2. These are concepts that we have done in paper 1, but they apply in our paper 2 integration of our topics. Let's answer that one. 5 minutes. Welcome back. I hope you had a good time. Like I said, we are integrating the topics. We are not doing paper 1, but we are using the concepts that are done in paper 1. Determine the value of cos 2a. Now, there's no way you can work with x plus 1 over x is equal to 3 cos a. And then how do you work with these two? Because maths is an interesting subject, I will start by writing down my 3 cos a is equal to x plus 1 over x. I know that I can have an identity for cos 2a that has cos squared, but how do I end up having that one there? So what I will do, I know that I am able to get this one if I square this side. I will get something which looks like what I have on my equation. Let me call this one 2 and I call this one 1, so that we are able to work with those two equations. So if I square on my right hand side, it means what I do on my left, I must also do on the right hand side. So if I square that one, I will get 9 cos squared a is equal to, when I square that one, I'll get x squared. Remember, when we square, we are saying it's x plus 1 over x times x plus 1 over x, and this will give us x squared. This multiplied x times 1 over x will give us 1. 1 over x times x will give us 1. And 1 over x times 1 over x will give us 1 over x squared. So this will give us x squared plus 2 plus 1 over x squared. But I know that this is 9 cos squared a is equal to x squared plus 1 over x squared plus 2. But I have the value of x squared plus 1 over x squared. This will give me 9 cos squared a is equal to, I'll then substitute the value of x squared plus 1 over x squared, which is 2, and I get 2 plus 2. I will get cos squared a is equal to 4. 9 cos squared a is equal to 4. And then this will now give me my cos squared a is equal to 4 over 9. Now, but I know I have an identity for cos 2a that has cos squared, and the identity now becomes cos 2a is equal to 2 cos squared a minus 1, and I will then substitute. In place of cos squared, I will put my 4 over 9 minus 1, and I'll get my cos 2a as 8 over 9 minus 1, and cos 2a will be given by negative 1 over 9. Interesting application of our trigonometry there. Now, so as you can see, it's not a straightforward question, but it requires us to have a knowledge of algebra to help us solve these questions. Now, I hope you have seen the way our trigonometric questions are coming by. For the first part, for our cast diagrams, you know that they can either give you a diagram or they can give you an equation like 5 cos theta minus 3 is equal to 0. Then you are given theta is between which range, then you will need to draw a diagram for you to get the quadrant. Then you are able to solve whatever questions are asked there. Then you also have our identities, where you are supposed to simplify or get a value. And remember also, we have to make use of our special angles. We did not use those because we have been using special angles since grade 10, so we have to look at those. And then we are also going to have questions like this question 6.4, where you are supposed to think outside the box and then use your identities to show whatever is asked. So this is how we did that one, and we got our answer, then we got our answer, then we got our answer as -1/9. Let's move on now to our trigonometric equations. Now, we talked about this the previous lesson, so I'll go a bit faster now. Remember, we have the different types of our equations. I will show them to you as we move along. But what is important is to identify the quadrant where our solution lies. For example, you would have either factorized or simplified whatever expressions that you are having. Then you get sine x is equal to -0,5. We get our reference angle, and we know that sine is negative in quadrant 3 and 4, so our solution will be in quadrant 3. In quadrant 3, it's 180 plus our reference angle plus k times 360, where 360 is the period of our sine function and our cos function, and for our tan function the period is 180 degrees. You will see that. So our solutions will be 2 like that. And then do not forget to write k times 360, k element of integers. This part always has a mark for the period and k. We move on to the next one, the method of solving, where we use the graphical method. Remember, I have drawn the graph of sine x. If you are given that sine is equal to a half, what the general solution is trying to do, remember I've just drawn this to up to 360 degrees, but we know that this continues. It also continues in the negative direction like that. So what the general solution is trying to do is to identify all these parts where our wave, which is our sine function, is intersecting the horizontal red line. That's how we get the general solution. And you will find out that this solution will be in quadrant 2, this one will be in quadrant 1. It will repeat itself after a period of 360 degrees. We will have that one as a star. After a period of 360 degrees, we have that solution as a star, and then we have that one as a dot. It will repeat itself after a complete cycle, which is 360 degrees. This can either occur in the positive direction or going in the negative direction again. As you can see, this solution will repeat itself after a period of 360 degrees. This one will also repeat itself after a period of 360 degrees in the negative direction. So if we are supposed to find a solution in the given interval, then it means we should substitute our integers to get the solutions in the given interval. So that's how we solve our trigonometric functions using the graph. So here you can either use plus minus so that you are able to get, if it's negative, then it means you are looking at where the function is negative. If it's positive, where the function is positive. It caters for all the solutions. Now, these are the types of questions that are asked that we did in grade 11, for example. You are given that sine A, solve for sine A if 3 sine A 2A is equal to -1 in the given interval. What is the first thing that we are going to do? We must make sine 2a will be equal to negative 1 over 3. Now, negative 1 over 3, this means our solution in which quadrants is sine negative. We know that it's quadrant 3 and quadrant 4. So what will we do next? We find our reference angle, and our reference angle will be shift sine 1 over 3. We ignore the sign because we know that it helps us get the quadrant. We'll get our solution as 19,47 degrees. From there on, we find our solution in quadrant number 3. It will be given by 2a is equal to 180 plus our reference angle 19,47 degrees plus k times 360 k element of integers. And this will mean our 2a is equal to 180. It gives us 199,47 plus k times 360 degrees, k element of integers. We want a not 2a. We divide both sides by 2. This will give us 99,7. Is it 7? Let me check. We get 99,74 plus k times, you divide by 2. Our period becomes 180 there, k element of integers. That's our solution in quadrant 3. For quadrant 4, it will be our 2a will be equal to 360 degrees minus 19,47 degrees plus k times 360, k element of integers. Now, this will give 2a as 340 degrees, 53 plus k times 360 degrees, k element of integers. We then divide by 2, we'll get our a as 170,27 plus k times 180 degrees, k element of integers. Are we done? Nope. We have to find the solutions in the given interval. Our interval is between negative 180 degrees and 360 degrees. So the values of a will be elements of, if you check, if our k is 0, it means our solution will be 99,74. So 99,74 is a solution. 170,27 is also a solution. Let's find the others. What will you do? You substitute for the values of k. If our k is 0, we found our solution as 99,74, looking at this solution. If our k is 1, it will be 99,74 plus 180, and that will give us our answer as 279, and you'll find that 279 is part of the interval. It's above negative 180 but less than, so I'll put another one, 279,74 degrees. And then when our k is 2, this takes us outside the interval. Let's try negative 1. If we have negative 1, our solution becomes, you will find out that it's 99,74 minus 180, and that will give our solution as negative 80,26 degrees. It's within the interval. If our k is -2, we will get our solution as 99.74 minus 360 degrees, and that will give us -260 degrees. It's outside the interval, so we ignore that one. So we are done with this solution. We move on to the next one. We said if our k is 0, we get 170.27. If our k is 100 is 1, we'll get 180 plus 170. It will give us, we will get 170.27 plus 180 degrees. We get our answer as 350.27. It's part of the interval, 350 degrees, 27. And then we cannot go further than this. If we multiply by 2, it's more than 360. It won't help us. Let's move in the negative direction. We will have 170.24 minus 180, and we get our answer as negative. We get negative 9.73. It's part of the interval. We move on to the next one. If we put negative 180, we will get, we found that one. If we subtract, if we have 170.27 minus 360, we get our solution as negative 189, and it's outside the interval, so we stop there. So these will be the solutions within the given interval. The next question says, find the general solution of 2 sine x minus cos x. This is the other type of questions where you will have this as 2 sine x is equal to 3 cos x. You divide by cos, and then you will get this as cos x, and we get this as 2 tan x is equal to 3. We get tan x as 3 over 2. Then from there you find your general solution, and we'll get our reference angle as shift tan 3 over 2, and we get our x as 56.31 degrees plus k times 180 degrees, k element of integers. If you want to use 360 as a period, then it means you will have to find your solution in quadrant 1 as well as in quadrant 3, because that is where tan is positive. We'll move along to the next type, where the next type of our solution, we are having a sine and a cos, and we can't divide by sine or by cos here because it will not give us tan because of the alpha plus 30 degrees. So this one, it's a cofunction. Our aim is either to convert this sine alpha so that it becomes cos, and I know that sine alpha, I can get it as cos 90 minus alpha is equal to cos alpha plus 30 degrees. Then we make one of the angles the reference angle, and then we work with 90 minus alpha is equal to alpha plus 30 plus k times 360, k element of integers. We find our solution, then we simplify. Now, in the interest of time, you will do this later on because I know we have done something like this in our classes. Let's move on to the next item. I will give you 6 minutes to answer that question. This is the quadratic type of our trigonometric equations. Please solve it. 6 minutes. You can be working on it now. Welcome back. I hope we're able to find the general solution for the equation. Now, as I indicated, so this is the other type, which is the quadratic type, which requires us to know our factorization. But what is the key thing? Here I have sine, here I have cos. But I know that my sine, I can have it as an identity. So I can write this equation, make sure that it's only one trigonometric ratio that is there. So I have sine and cos. So the one that is easier to change is this sine squared. Instead of sine squared, I can write 6, 1 minus cos squared x plus 7 cos x minus 3 equals to 0. 6 times 1 will give me 6 minus 6 cos squared x plus 7 cos x minus 3 equals to 0. 6 minus 3, I'll have negative 6 cos squared x plus 7 cos x. 6 minus 3 plus 3 equals to 0. I divide throughout by negative, I'll get 6 cos squared x minus 7 cos x plus minus 3 equal to 0 because I've divided throughout by a negative. And then from here, I need to factorize. Factors of 6. Now, if I'm able to factorize 6x squared minus 7x minus 3, this becomes easy to work with. Now, in the interest of time, we got there and we'll get this as 6 cos squared x minus 7 cos x minus 7. Then we factorize. This becomes 3 cos x plus 1. And we have 2 cos x minus 3, and we get the values of x as that. I always ask my learners, why is cos x equal to 3 over 2 not applicable? And people just say, because on the calculator it's saying error or it's undefined. Remember, we said these are ratios, and we defined the cos ratio as x over r. In any given right-angled triangle, you cannot have a side which is longer than the hypotenuse. Hence, our maximum and minimum for our cos, it's either -1 and the maximum will be +1, depending on the function. Hence, our cos x cannot be more than 1 or cannot be less than -1. So we will find our reference angle and get our answer as 109.47. This is in the second quadrant because cos is negative in the second and third quadrant. And in the third quadrant, our solution will be that, and we get our 6 marks there. We move on now to our trigonometric graphs. Our trigonometric graphs, we know that we have our functions in the form a sine x, y cos x, and we know that we have got our amplitude shifts. Our amplitude is defined as the distance between the maximum and minimum y values, and we know that amplitude becomes half the distance between our maximum and our minimum y values. Amplitude does not have a sign. It can neither be negative or it's always positive, sorry. It cannot be negative. So we also look at our vertical shifts. Sine x plus 1, we know that is the graph of sine shifted 1 unit up. Period shift, if I have sine 2x, we know that the graph of sine x, the period is 360 degrees. If I have sine 2x, the period becomes 180 degrees. You have the period. So now this is explained there. So if you are given a graph, please quickly draw the graphs of the original function so that you are able to see what is different. If we are given cos 3x, the period becomes 120. And if you are given y is equal to tan 4x, the period becomes 45 degrees because the period for a tan function is 180 degrees. We divide by that. Now, also, we have our A, which affects our amplitude. It either stretches or compresses the function. We have looked at that. And then we also have our mixed shifts, where when you are given a function like that one, where your amplitude, your graph is stretched, whilst your period is also doubled. So that's how we get those shifts. Our horizontal shifts, the same way we are having shifts in our paper 1 functions. If it's a plus, the graph shifts p units to the left. If it's a minus, x minus, then our function will shift p units to the right. For example, if we're given y is equal to sine x plus 30 degrees, it means the graph of sine x is shifted 30 degrees to the left. If we have y is equal to sine x minus 30 degrees, the graph of y equals to x is shifted 30 degrees to the right. And then we should be able now to look at questions of our trigonometric functions. So in these questions, either we'll be given a sketch and you are expected to interpret. When you are interpreting, we'll be asked questions about the amplitude, the maximum turning point, the minimum turning point, the interval where the function is increasing or decreasing, as well as knowing our shifts to the left, our shifts to the right, and so on and so on. But then in some instances, we'll be expected to sketch the graph. When we are sketching the graph, we must know our basic shape for the function. If it's a sine graph, where does it have a maximum? Where does it have a minimum? Where do we get our x-intercepts, our y-intercepts? So those basic things, we must know how to sketch the graph of sine x, cos x, and tan x, so that we are able now to answer questions that involve the variations of these graphs as they are asked in our questions. Now, I will give you 5 minutes to answer that question number 7, after which we will do it together. Let's answer question number 7. 5 minutes. We will mark it together, then we move on to problems that involve 2D and 3D trigonometry.
I want you to ask yourself this.
Okay. Ngisafrizile phela awasho ukuthi hey clear.
Ngisafuna something to put ifake it.
Ungahambile. Hayi, ayikho inkinga baba. Babuza bathini?
Ibonene ufuna le yaka 1 plus x squared plus 1 plus.
Oh,
Yeah, so explain yona mangiqeda ngiyaphuma.
amtshela
Amanye ngizowaphendula le.
kubonga mina basi.
Ngibonga kakhulu.
Thank you so much.
Amanye ngizowaphendula le mangifika le phambili.
Okay. Hayi, kodwa ke ngisukume kunini ngihleli. Zoze nginamathele kule studio.
Ngamanzi ami le ngane phezulu.
Okay.
Believe in yourself. Believe a little more in yourself. Because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing because this can be done and you can be great. Believe in yourself. Believe a little more in yourself because to those
Welcome back. I hope you were able to sketch the graph. Now, in the diagram below, the graph of f of x is equal to negative 2 sine x is drawn for the interval between negative 180 degrees and 180 degrees. Now, if the graph is sketched, you are able to see that this graph of f has a maximum at negative 90 degrees and positive 2. These are our intercepts with the axis, and it has a minimum at 90 degrees and negative 2. Now, let's look at 7.1. On the grid provided in the answer book, draw the graph of g of x is equal to cos x minus 60 degrees for x element negative 180. Clearly show all your intercepts with the axis and the turning points on the graph. Now, we want the graph of cos x minus 60 degrees. We must know the shape of the graph of original graph of cos x, and it's shifted. It's a minus 60 degrees. We said it shifts 60 degrees to the right, meaning our y-intercept should shift 60 degrees to the right. Our maximum for our cos function must move 60 degrees to the right, and our graph would look something like this. If you check, this is now our negative 120 degrees and negative 1. This becomes negative 30 degrees and 0. Our maximum is at 60 degrees and 1. And this becomes 150 degrees and 0. Now, you can see on the original graph of sine, we know that our maximum will be there. It would look something like that. The red graph is the graph of cos x, and the black graph is the graph shifted 60 degrees to the right. Now, if you do not know the original graph, it becomes difficult for you to sketch that one because you don't know where to put your maximum, where to put your x-intercepts, and so on and so on. Now, so for this one, for your maximum turning points, you will get 1 mark, and your x-intercepts, you also get your shape, 3 marks. It has to be a smooth curve. Please do not use a ruler to join those points. It has to be just a smooth curve using freehand. Let's make it a smooth curve. We have our graph like that. So we get our 3 marks there. We move on to the next question. Use the graphs to determine the values of x in the interval x between negative 180 and 180 degrees, for which f of x minus g of x is equal to 1. You are looking at the graph. Where do you get the difference between f of x and g of x being equal to 1? You are able to see there our y value there is 0, our y value there is 1. Which one is above? It's f of x. So if you say that minus that, we get 1 minus 0 will give us 1. And what is our value there? We must get the angle. We know that this is the negative 30 degrees. This is negative 60, negative 120, negative 150. You can deduce this from the scale that is used on your graph. So each of the blocks represent 30 degrees there. And we are able to use that. So it will be 30 degrees, 60 degrees, then 90, then 120 degrees, then 150 degrees, then 180 degrees. So our solution for that one, I skipped the first one. We're supposed to write down the period for the graph of f is equal to f of 3x. So the period will be 120 because the original graph of, let me quickly play back. We have the graph of sine, right, quickly. So our f of x is equal to negative 2 sine x, and if you check the period now, it's from negative 180 to 180, which gives us 360. So to find the period for that one, it will be 360 degrees divided by 3. Hence, we get that 120 degrees. So if we are given the period, we are able to find the missing values of A, B, and C depending on the question. Now, let's move on to the next one. It says, write down the range of k if k of x is equal to half of g of x plus 1. We already have our g of x as cos x minus 60 degrees. What is the range for g of x? We said, when we sketch the graph, we said 60 degrees and 1, negative 120 degrees and negative 1, and our x-intercepts, we got them 150 and 0. We have our negative 30 degrees and 0, and so on. So now, if you look at the range, it's between -1 and 1, because that's our minimum, that's our maximum. That's the range for g of x. So we got -1 and 1. Then to get the range for half of g of x, you are halving the maximum and the minimum. You'll get negative half as your minimum and half as your maximum. You add 1 to these, then you will get negative half plus 1, because it only affects our maximum and minimum turning points. You will find you will have half and 3/2 as our maximum. So it's 2 marks. So method, and for the answer you get your 2 marks there. The others, we're able to see them. Let's look at our 2D and 3D problems. We are solving triangles. You always have to state in which triangle you are working with. You have to redraw the triangle so that it's easier for you to see what you have and to work out what you do not have. You always start with a triangle that has most information so that you are able to find the one that you are missing. We go back to the basics. In any given right angle triangle, sine is opposite over hypotenuse. Cos of any angle is given by adjacent over hypotenuse. So if I have a right angle triangle like that, I know that A, B, C, what you normally do, we use small letters to mark those sides that are opposite to the angles. So our hypotenuse, the length of the hypotenuse is small letter b, the length of this side BC is small letter a, and the length of that side BC. So if I want, for example, sine of angle C, it becomes the opposite, which is small letter c over b, or I can use my AB over my AC as the sine of that angle. Depending on how the question is asked, we can use any of those, but we go back to the basics. We must know opposite side, adjacent side, and all this is dependent on the angle that you are working with. So if I'm working with angle C, the opposite is AB. If I'm working with angle A, the opposite becomes the side BC, the side opposite the angle all the time. Let's move on. Now, we use our sine rule. Given in any triangle, sine A over A is equal to sine B over B, which is equal to sine C over small letter c, and the other way around. When we are given the length of the sides, A over sine A is equal to length B over sine B, which is equal to C over sine C. Then we are also able to use our cosine rule and our area rule there. Now, when do we use sine rule or area rule? The first one, it's when our triangle is not right angled. And then when we are given two sides and a non-included angle, and when we are given more than one angle and a side. By an included angle, I'm saying if I'm given a triangle like that, A, B, C. If I'm given the length, small letter c, and the length, small letter a, then I'm given this angle here. This is an included angle. I cannot use sine rule, but I can instead use cosine rule, because for me to use cosine rule, the triangle must not be right angled. I must be given two sides and an included angle, in which case I'll be given that angle there. I'm able to use that one. And then also when I'm given three sides. The area rule, it's when I'm given two sides and an included angle and the triangle is not right angled. I can use my area rule. Now, because of time, I will work question 8 with you. I wouldn't give you a chance to answer it because time is not allowing anymore. But the key thing, let's read the information that is given. In the diagram below, T is a hook on the ceiling of an art gallery. Point Q, S, and R are on the same horizontal plane from where 3 people are observing the hook T. The angle of elevation from Q to T is X. Then we are given the other information. QSR is equal to 90 plus X degrees. QRS is equal to X. And we are also given that QR is equal to 5 units. And we are given that TS is equal to SQ. If this information is not indicated on the diagram, please add this information to the diagram so that it's easy for you to see what can easily work for you. The first question, we are supposed to prove that QS is equal to we are given that we are supposed to prove that QS is equal to 5 tan X. So, what is important there? Redraw the triangle that can help you get the answer. So, in this case, I will say in triangle QRS. So, redraw the triangle so that you are able to see. It's not right angled. I have my Q here, I've got my R here, and I've got my S here. My angle here is 90 degrees plus X. That angle there is going to be X. I'm given this side as 5. So it means sine rule is going to help me answer this question. I want to find QS, that side, and its opposite, that angle. I'm given this side, and I'm given the angle opposite that side. So I will write down my sine rule. QS over sine X is equal to QR over sine angle S. And then from there on, I will substitute and then get QS over sine X is equal to QR over sine 90 plus X. And this will now give me QR is 5. The reduction of sine 90 plus X is cos X. And then I will have now my QS as equal to 5 sine X over cos X, which gives my QS as 5 sine over cos. It's an identity for tan X. Then I get my 3 marks there. It's done. We have to prove that the length of QT is equal to 10 sine X. We move on to the next slide. Let's be trying 8.2 whilst we fix something here. We have to prove that the length of QT is equal to 10 sine X. Okay, welcome back. I hope we're able to solve our 8.2. Now for 8.2, prove that the length of QT is equal to 10 sine x. If you look at QT, what I will always encourage, please redraw the triangle so that you are able to visualize what's happening. We just found the length of QS. So this is our QST. So we want this angle is given as x. This angle T will also be x because these are angles opposite equal sides. And we know that sum of angles in a triangle is 180 degrees. So it means angle S is going to be 180 minus our 2x using our angles there. QS, we just found it as 5 tan x, which means this one is also 5 tan x. So from there on, we need to prove the length of QT. So QT becomes, QT is this side, the angle opposite is angle S. TS, we have our TS, which is opposite this angle X, and we substitute and we will get QT over sine 2x when we use our reductions is equal to 5 tan x over sine x. We use the identity for tan, and we also use the double angle identity. You will find out that this cos and that cos give us 1, and then this sine and that sine will give us 1, and then 5 times 2 will give us our answer as 10 sine x. Alternatively, we can use the cosine rule. As you have seen there, we can substitute our length of QS and the length of TS, and then our angle QST, we found it as that, and then using our cosine rule, we will get QT squared is equal to 50 tan squared x multiplied by 1 plus cos 2x. Substituting the identities, you will find out that we will have tan squared, it's sine squared x over cos squared x. We multiply it by 2 cos squared x, and that will give us our 100 sine squared x. And then the square root of that, it's a distance, it will give us 10 sine x. That's the alternative method we can use there. We're supposed to calculate the area of triangle TQR. TQR. You are able to see that triangle TQR, and we are going to use the area rule. We substitute and we get our answer as 9,93 square units. Please, even if 8.2 you failed to get it, but do not leave these questions like 8.3 because you are able to get it without the answer for 8.2. So the common mistakes that we make, we talked about the amplitude. We confuse the amplitude with the period. We make assumptions. We do incorrect simplification. You saw when we are using the sine rule, cosine rule, and area rule, there's a lot of simplification that we do. Please, let's make sure that we check if our steps make sense. When we are doing reductions, correct sign of our trigonometric ratios. Let's avoid working with more than one triangle. Always work with one triangle at a time for our 2D and 3D problems. We should not use a calculator if the question states clearly that a calculator should not be used. In summary, please let's analyze the given information in all the given questions, whether statistics, analytical geometry, Euclidean geometry, let's analyze the given information. We do not measure on the diagrams because diagrams are not drawn to scale. We must use our diagrams effectively. Let's add information to our diagrams, label correctly, and we should take note of the notations that we use for our angles, equal lengths, and so on. Let's write all the given information on the diagram and add as we get more information so that you'll see that subsequent answers become easy to get once we have information on the diagram. We draw additional lines so that we get a clear picture of what is happening. Like I said, you cannot use a follow-up answer to answer a previous question. Let's also know the properties of our triangles, quadrilaterals. Let's revise them thoroughly as they come under analytical geometry as well as in Euclidean geometry. We must be able also to know those properties. Use of color is encouraged. We cannot emphasize this. We refrain from making assumptions. Good luck for our paper 2 examination and all the best. We've got this. We are passing. All the best for Monday, and thank you so much. Let's continue to practice and revise. Like I said, let's avoid discussing paper 1. It's over, and whatever things that come for you, please just ignore because it's not going to help. Let's focus on the revision of paper 2. I thank you. Oh. Shy.
Hours.
Exactly.
Hours for me.
Aren't you? It's because the pen gets spices.
I am busy. And I've always taken say white. Okay.
Yo, pay loga 2023.
What's up, banana still?
Yo. Babhala manje baqedile.
I'm still, I'm a president. I'm a president.
Ikisimusi